Thank you. Hi everyone, so thank you for coming along to the session. I hope you've had a fantastic time so far. So hopefully you're in the right session. This is automated visual regression testing, the missing part potentially to CI pipeline. I'm going to be sharing some code, so if you're sitting at the back, you may want to move forward, so now's the best time. We're going to be looking at manual testing, why quite often it's not enough alone. We're going to be looking at some common issues with end-to-end testing. And when I talk about end-to-end testing, I'm primarily talking about Selenium. We're going to be looking at ways to overcome some of the issues you may face, and then looking at ways that potentially we can use visual testing. So visual testing can sort of piggyback off Selenium tests and start to add a lot more value to the types of checks that we do. So why automate end-to-end UI tests? Well, these are just two reasons. Of course, it depends on the person who's writing the tests, but they can be more reliable. As it's a machine as well, it can be quicker to execute. Of course, it depends on the type of code that you write, how clean it is, how efficient, but it tends to be a lot more efficient and quicker to run than humans. There are lots of sort of common UI issues. So the biggest thing for me is investment. So that's not just to be able to go out and buy a tool or framework. It's the investment to get people on board. So in previous companies I've worked, and in my current one, we've got a team of maybe 30 testers, and we're trying to get them to start to look to see where we can start to add value. So where we can start to automate a lot of the things we do manually. And just trying to show someone, perhaps, you're probably all developers, I'm guessing. Can I have a show of hands if you're a developer? Okay, not so many. Surprising. Or you're sleeping, are you awake? Yeah. So yeah, when you start looking at a new IDE, so VS Code, Visual Studio, one of the JetBrains tools, different languages, there's a lot to take on board, and that's before you start to even write, a test. And it's only practical as well when you're running, when you want to run tests over and over again. If you're just doing a throwaway test, it's probably better to be suited for a manual test. You're not going to want to invest in time in creating these types of tests. And the most important thing for this talk, or if you start to look at visual testing, is automation. Typically, it doesn't entail human observation. So I know there's things like AI, which is fantastic, but typical types of tests that you encounter, it doesn't help to say that things look how you expect. And it can be a slippery slope as well. Hopefully you can see this from the back. If you can't, I'll just quickly say what it says. So somebody's basically asking for the salt, and the colleague is just trying to write an automated test for it, or something to try and do that for them. And I see this too many times, whereby just because someone gets a tool, and I'm going to pick on Selenium, I really like Selenium, but people tend to think, oh, wow, I can actually start writing checks for all these different things. And they get carried away, and they end up writing so many end-to-end checks and logical checks that it's not really adding any value, and they're doing things just because they can. And in the end, you end up building up these really difficult to maintain flaky tests, and they don't give you enough feedback quick enough. So hopefully some of you will recognize this. It's the ice cream cone anti-pattern, and this is the reverse of the typical sort of test automation pyramid that you may have seen. And what this is trying to show is that the lower down the stack you are, the tests tend to run faster. The higher up, the tests are slower. Likewise, the lower down the pyramid, the tests are cheaper to implement and maintain. And then the further up the stack you go, then the tests become a lot more difficult or more expensive to implement and maintain. And I see this quite often whereby people have just got carried away with writing these tests with Selenium just because they can. And it's a really slippery slope, because I've seen tests whereby it's taken potentially up to 4 hours for these tests come regression day to give some feedback, and it's just not quick enough. So within teams, you start having conversations, and you're trying to get, it's very difficult, but you try to get developers and testers talking. For some reason, they don't like to sort of communicate. And it's a shame, because we start to add value. Developers often feel they can't pair with testers because they feel that what's a tester going to offer to me? And a tester potentially feels, well, I can't add any sort of technical expertise to this. But whilst the developer is quite technical, a tester has or tends to have more domain knowledge. So together you can start to work together to push the test further down the stack. again, further down the stack you are writing your tests, the quicker the feedback. So teams start to write unit tests, and it's really good. There's a problem. So we're missing integration service tests. And this is what happens. So when you have tests which are just purely testing the unit level, and you don't try to have tests going all the way through the stack, how do you know that your pieces of code work well together? So you need to try and get tests all the way through. And something I like to call fragile testing. So when you're relying on tests that are primarily sort of end-to-end UI tests, it's just not quick enough feedback. The whole point, if you work especially as part of an agile team, is that you want to fail fast. You want to be able to adapt. So you want to be able to add value at every layer. So if you were sort of writing your tests as part of your CI pipeline, you'd push your code, you'd get it to build, then you'd get it to run your unit integration tests, then deploy, maybe then run your UI tests. You don't want to wait until you've deployed your code to run the tests and then realize that it's knackered. You want to be able to test at each level and provide feedback so you can fail fast. So this is the testing pyramid. Sorry, the text has gone off the screen slightly. I tried to adjust it. If you go on Martin Fowler's blog, he talks about this a lot more than I'm going to. But typically, there's a lot of debate in the testing world about whether this is right or wrong. I quite like it. And what this is just saying, so perhaps the levels of tests will differ slightly, but it's just trying to illustrate that you should be pushing for tests further down the stack, getting quicker feedback. So try to get more unit integration service tests, and then perhaps for the UI level, just a sort of happy path through. Don't try to write your business logic tests through the UI. Try to add the test further down. And at the top, you're always going to have this manual and exploratory testing. So it doesn't matter what types of checks or automated tests you write. They are just checks. They're only checking the things you tell them to check. So you're still going to want to do manual and exploratory testing. So why not stick to manual testing then? We've already said that the UI tests can be flaky and they're slow. But the problem is that it's time intensive. So if you're trying to run through scripts, it takes a while. Every 2 weeks we try to release software. We've got 25 testers who are trying to run through these scripts, and it takes a long time. And while they're doing that, they could have been adding value elsewhere, getting some checks to just run through some happy paths, give them some quick feedback. And if you work as part of an agile team, there are meetings every 5 minutes. So you'll have your stand-ups in the morning, you'll have your sort of various ceremonies like Three Amigos, refinement, end of the sprint, you'll have your retrospectives and your sort of reviews. And there's so many distractions, it's very easy to make a mistake. And it's only, again, practical when you have to run the test over and over again, when you have to run the test once or twice. If you're running through the test over and over again, this could be an opportunity for you and your team. But it can be quite frustrating because I've seen teams who've invested a lot of time in creating test automation frameworks. And even when you try to give the wheels for the cart to try and speed things along, people just don't have the time to stop. And it's because they're working in these quick cycles and they're trying to release fast. They're agile, they need to be able to quickly get software out the door. But the problem is they're relying so much on slow tests or manual tests, they're just not able to stop to adjust. And it's a catch-22. So again, sorry, there should be an arrow going from because to because and back. It's a catch-22 because people never stop because they don't have time. So they don't automate because they don't have time, but they don't have time because they don't automate. And it's about breaking that cycle because unless you try to work together as a team, we're all responsible for quality. It's not a tester's problem. Once you've completed a piece of code, we all should be striving to get the best bit of code we can out the door as a team. And this is something we try to do. So we have WIP limits, or work in progress limits, which says if there's 5 people on a team, what we do is we say there's a WIP limit of 5. So you can only have, for all of the work you accept in that sprint, 5 pieces of work in progress at once. So what this allows us to do is it forces people to pair. And then all of a sudden you can start having these sessions whereby you'll have a developer and a tester, and you start to add the value then and identify areas that we can potentially get quicker feedback. And it can be quite daunting because when you start looking at automated testing for the UI, there's just so many options. And when you type into Google, the thing that comes up quite often is Selenium. I'll go on to why in a second, but there's so many options. So if you want to not write code, there's Visual Studio coded UI with you have a nice GUI, you can click record, run through the application, it records steps, and you just play it back. It's quite nice. But it'll only run in, I think, IE. There's things for depending on the browser that you want to target, so Selendroid, perhaps. Some of these are free, some of them are not. What languages are your team using? So you're going to want to try and fit in a framework, especially if you're new to writing automation. That ties in with the team so you can get the support. There's just so many different options, and it really depends. Again, investment is another thing. How well known is this tool or framework? What's the community support like? You know, is there going to be a lot of bloat that you're going to inherit? There's lots of things to consider. So I'm not sure if it's just a Welsh thing, but the majority of companies recruit for automation testers or developers in test, as they like to call them, who can use Selenium. And I believe these are some of the reasons. I could be wrong. One of the strongest things is that they have a massive community. So if you get stuck, you can really get the support you need. It's open source, so if you want to see how it works, you can just jump into the code. You can go on GitHub, you can see exactly how it works. You can add to it. You can operate on almost any operating system. There's so much language support as well, so it's probably whatever language you're using, this will support it. And also, the browser support is fantastic. So it supports Opera, Chrome, IE, all of the versions, Firefox, Safari. You can use something like Appium. So it was on the previous slide, whereby you can, it's free, you can, sorry, I skipped my slide. It's free and you can basically use your Selenium tests, pass it through Appium, and then all of a sudden you can start automating your tests on an iOS or Android device. So you can extend the driver support for Selenium, so it's really powerful. For us, it was important because we had to support for our customers Chrome, IE, and Firefox. But again, I'm going to bang on about this. It's not a silver bullet. Just because it seems to work, really check through your tests if you're using it, because I believe you should just be doing your happy path tests. If it feels like the tests are taking too long, or I don't know, you seem to be writing lots of lines of code for it just to get a sort of happy path, probably that's a code smell. You want to check it out. Have discussions within your team. There's lots of issues with sort of browser compatibility. So when you start to try to support lots of different browsers, the speed in which tests take to execute differ. So all of a sudden you have to start telling, so if I'm using Firefox, wait a second, or do a thread.sleep. If I'm in IE, it's going to render quickly, so I don't have to do this. So all of a sudden, you have to start accounting for all these differences within driver types. And whilst it's not a problem for typical end-to-end testing, when you start looking at visual testing, the way the browsers render are different as well, so you have to take that into consideration. And again, execution speed. It does take a long time to run a Selenium test. So some of the applications that I've worked with, we'll have our customer, which I'll call an agent, and their customer, which is a client. So before we can even get through a happy path of a test, the agent has to log in, create a session, send that across to another driver window, which is our client, and then they start the transaction. So it takes a long time, and it can be really slow. And when you start accounting for lots of different driver types and putting in weights, and if I'm using this browser, do a send keys.click. If I'm in this driver type, do a send keys.enter. All of a sudden, the maintainability of your tests become quite a chore. So I wanted to ask, apart from end-to-end UI testing, if you just had to test this form on the right-hand side, how valuable are these tests? So what they're actually doing, it's C# and Selenium, and it's just checking text. So there was a call late one Friday into support, and the customer was unable to use the form. The support person checked the tests, all the tests passed. What had actually happened, there was a CSS breaking change. The element was actually on the page, but it was out of view. And the problem is that the Selenium tests, they can tell you that elements exist somewhere in the DOM or the document object model, but they can't actually say that they exist exactly where you expect them. So very quickly, I'm a bit conscious of time, there's some things you can do. So if you want to start writing cleaner automation tests, you can check out the page object patterns. So Martin Fowler, again, explains this a lot better than I will, because I'm going to brush over it. But if you're writing tests, and in each of your tests you're interacting with the same elements, As soon as if that element changes, all of a sudden it's going to break your tests, if the ID, for example, that you use changes. So what you can do is you can extract out the way that you interact with that element into a page helper object. So if the element ID changes, you update it in one place in the object, and all your tests then will pass. So it's a really nice way of trying to keep your tests clean. And very quickly as well, QA selectors. So these are really nice. So if you look at this form that we had, the top left-hand corner is the markup for it. What you can start to do, so you can put this in a class or a data tag. You can say for the cancel button, so we label everything QA hyphen, the element type, which is button hyphen cancel, because this is the name of the element. And again, QA hyphen button hyphen submit. So what this allows us to do is, when we start writing our tests, especially when we're trying to get people on board with automation, they no longer have to think, well, how do I find this element? Or this element shares the same class name as another element. They can just do QA hyphen button hyphen submit, and they can just find it. And in the tests, they're always doing driver.find element by CSS selector or class. So it makes the test really clean. And when they're working within the teams, if somebody makes a change to the front end, they're less likely to make a breaking change because they can see there's a QA selector attached to that element. So it's really good. So we're going to play a game just to make sure that everybody's awake. So we're going to play a quick game to spot the difference. With the 30 seconds, we'll see how many you can find. Don't shout them out. Try and keep them till the end if you can. Okay, so very quickly, did anybody find 3? If you could put your hands up. Nobody? 1, keep your hand up if you found 4. No? Okay, very good though. So there were 7. There's only 6 things highlighted here. I'll explain why in a second. So if you're using Selenium UI tests, only 4 of these things would have got found. So very quickly in the top left, the image changed slightly. It wouldn't have got picked up. We had a text change, speakers was changed to speaker. We had top right, there was a blue underline. I appreciate it's probably very difficult from the back, sorry. Again, in the image, the R changed to the D on the roller banner. We had a number 1, so that would have got picked up. The date was from 2010 to 2018, and then a full stop for speakers. So it's very difficult. And even when you spend a lot of time, we only had 30 seconds, we still didn't find all the differences. But even if you use Selenium UI test, you're still probably not going to find a lot of the sort of differences. That could be quite critical for your business, depending on your line of work. And how do you know when to stop? How do you know when enough is enough? So how can we start to add more value to your tests then? What if we could say, for example, I've got a base image. This is how I expect the web page to look. And every time I run my Selenium UI tests, I want you to take a snapshot, and does it match what I expect? So there's lots of options. When you start to look at visual testing, there are so many different options out there. Not quite as much as the Selenium UI type tests, but still, there's a lot to consider. And again, it comes down to costs. Not all of these are free. The languages in which you may write your tests, some of these are JavaScript. Apply tools, I bang on about this all the time. I don't work for them. They're really good. They're unlike all the others and what I'm going to share today. So what they do is they use AI, and what they can do is, if you imagine you had 2 Twitter streams and you had 4 tweets, if the order changed slightly, it wouldn't matter because it's using AI and it knows that it's the same content, so it will still pass. You can use code to write your tests, and they've got a nice GUI, so it's definitely something to check out. But again, it's a bit of a minefield, so you have to start having to play around doing spikes. Don't just use a tool because somebody says it's a great tool. Every product's different. You have to see what works for you. The issues with other offerings for us were that they didn't work straight out of the box. So there are a number of things, really. Steep learning curve, trying to get people on board. We've just got them on to start writing Selenium UI tests. Costs. When you start to play around with a new tool, trying to prove its value to the business can be quite difficult. So the code I'm going to share now is basically something that I've knocked together. It's very rough and ready. I'll share a link very quickly at the end. But it's just to try and prove that these types of tests can start to add value. So it's been in development for just over a year, and there's many challenges because the way we write our software, again, developers and testers don't speak. It's very strange. And so what they do is they don't think about, well, how would somebody test this? And the testers don't speak to the developers, so they don't realize until they get the application to test that all of a sudden they've got elements that all share the same class names, or for some reason we've got generated IDs, so you can't use an ID. So it's quite challenging. And we found there are a lot of issues. So when you start looking at rendering and doing visual testing, not all drivers render the same. So this is a Google homepage taken a snapshot with a Google Chrome driver, and then we run the same test on a Firefox driver of the same page. And the pink boxes you see there is an output difference image of everywhere where the driver types thought the image match wasn't quite a success. So the execution speed, so what we're going to see here is there's a test, 4 lines of code. We specify an image, we give a URL, we say we've got a base image, open a driver window for Chrome, take a snapshot, quickly compare that image, and just in 4 seconds, we know that the Google homepage matched by using the same driver type. So it can be really quick. But again, don't get too excited about this, because this test is just piggybacking off Selenium. So if you have any sort of setup in order to get to that page first, or logins, you're still going to have that time. What this is actually doing, though, is it's actually providing more value from your test. You're not just checking text, you're checking colors, font sizes, padding, images, lots of different things. So it's really powerful. So we're going to play another quick game, human versus machine. So I wanted to prove to the business how quick this could be. So I took 2 images of Where's Wally, and I photoshopped one out. So I want to see how quick you can find them. So I'm going to zoom in, but these are the 2 images I gave to the machine. So there's a lot going on. I appreciate our applications aren't ever, or I hope not, quite this busy. But when there's a lot going on, it's very difficult to try and see wood for the trees. So has anybody found him? Yeah? Yeah, so he's up in the top right-hand corner. So it's really difficult. When there's lots of things going on, not just on a web page, but distractions within your teams, it's very difficult to try and, see something that, once you've seen it, it's quite obvious, I guess. So how quick was the machine? It was 293 milliseconds. And again, what you see is the pink boxes around the difference. So the machine found it straight away. When we start looking at maintainability, so this was our old code, all of a sudden, all we're doing now is specifying an image and a URL and saying we expect there's no difference. The top test, the 6 lines of code, they were just checking text. All of a sudden, we're getting padding, colors, font sizes. So it's giving us a lot more value for the types of checks we're writing. And you can take this further. So if you use SpecFlow or Cucumber, so SpecFlow is a .NET port of Cucumber, you can start to write scenarios. So again, if you work as part of an agile team, you have your given when thens. And what you can do is you can start to have your given when thens as scenarios. And the stubs at the bottom, or the steps, these never change. So you can write lots of different scenarios for different pages and images, but it'll run through the same bit of code. So you're not trying to maintain all this sort of difficult code anymore. You just have the same code, and you just specify your scenarios. You could take it further, and you could create a scenario context whereby you have a table, and you don't have lots of scenarios. You don't have lots of scenarios. You have a data table. You specify your images and your URLs, and then it'll just run through the same code. So you can just pass it through, and it's really, really powerful. Again, so this is an output of what you get from when you run the tool and it finds a difference. So by default, a lot of the different frameworks, not just the one I'm talking about today, they'll give you an output image so you can quickly see what the issue was. And this is really powerful. So we had this previously working with Team City, I think. And whenever the UI test would fail, so we'd have a UI test, and then visual testing. When the test would fail, we'd get them to attach as artifacts, and then we'd be able to reference it back to the code that was checked in, and we'd quickly be able to see, did we expect this difference or not, and then adjust for that. On the right-hand side, some of the frameworks offer this. So what this is actually showing is, again, from the back, if you can't quite see it, there's numbers. And it's where it believes that there's a subtle difference within that part of the image. So you can get a tolerance image output. And this is really handy, and I'll explain why in a few slides' time. It can be pixel perfect. So in the previous slide, we had the tolerance image. Again, I'll explain why it can be, but certainly if you run the tests on your own machine, which I'm guessing you're not going to constantly want to do, but if you run tests on your own machine, it's pixel perfect. As soon as you start working with other team members, hardware and other issues come into play, and we'll discuss that further in a while. Image quality difference. So as long as you're using the same hardware and the same driver type, it doesn't really matter. So when you start doing visual testing, there is no difference really. You set up profiles, so you say, well, this is the height and width of the window for this type of device or this device. Or you could link up to something like Android Studio or Appium, and you could start to use their sort of snapshots to take account for different devices. There's been a lot of challenges so far. The biggest one being that it's just myself who's been writing this, trying to prove to the business it can add value. And again, this is because our teams don't have time. We're trying to constantly deliver value for our customers, and we're still trying to get people to write UI end-to-end tests. So then to try and add something else to the plate, it's very difficult. So it's probably been the biggest challenge. Originally when I started, I assumed, so we saw in a previous slide, that the driver types render differently, so you can't use the same base image for each different driver you want to test. So what you have to do is you have to maintain the base image for each driver type. Now the frameworks are quite clever in that they can work out when you run a test what driver you're using, and then they'll create a base image for you if it doesn't exist, for example, and it'll prefix it with the driver type. So you may have chrome.homepage.png or Firefox. So something like that. So you have to start thinking of these things. And whilst it's not a problem for everybody, if you want to support lots of different devices, lots of different browser types, storage can build up quite quickly. So it's something to take into account. And how much value is it actually giving you? So it's not going to work for everybody. It's something to play around with and see if it actually adds any value for you. Don't just do it because it's cool or you've got it to work in your machine. That's great. But is it adding any value to your teams? You're going to have to maintain these types of tests. So screenshots. By default, a lot of the drivers, what they actually do is they'll give you what's in viewport. So it's a W3C standard. So at the very top left, what you see is what you get. It takes a snapshot of exactly what's in the driver window. So what we've done and what the other frameworks do, on the right-hand side, in the driver, you can inject JavaScript. I'm not sure how many people have used Selenium, but you can inject JavaScript. So we work out the height and width of the window, and then we take snapshots, and then we inject JavaScript to scroll through and then stitch the images together. So it's really powerful. Another cool thing that we do as well is, and the other frameworks do it as well, is that you can actually get down to the button level. So if you work with, for example, banks and lots of different banks, and they all have their own different branding, you can start to not even care about the overall look and feel of the website. You can just say, well, do all my headers look as expected, to my sidebars, to my buttons. And whilst visual testing probably wouldn't work for something like WordPress or Drupal because they're data-driven, if you take this approach, you could just check your sidebars or your buttons. So it's possible that could work for you. Screen resolution. So this really caught me out. 3 months into creating the project, I thought that, before I even felt it added any value, I was just excited, as most people are when they get things to work with the machine for the first time. So I ran off to the review, had some base images already created, ran the tests, but I had to remote desktop into another machine, and all of the tests failed. And it was absolutely, you can imagine, quite embarrassing. So what had happened, or it seems quite obvious now, but I'd maximized the driver window before I took the snapshot. So if you're going to do visual testing, don't maximize the window. Just set height and width, and then take the snapshot. So regardless of the size of the screen, you know the base images are always going to match the height and width. So it's just something to be careful of. I know it sounds silly and obvious now, but until you know it, you know. Responsive design, again, so what we've done when we've been playing around with this, so we've not decided to do this because it gets to a point where you're trying to automate things to save manual sort of involvement, but if you're trying to, you know, take account for lots of driver types and responsive design, you've all of a sudden got all these base images and things you have to maintain. So it's something to keep in mind because you don't want to be spending a lot of time maintaining these base images and all the different images that get output. So, yeah, so this is what I was referring to, so hardware issues. Whenever you look at visual testing online, this is the reason why most people say, don't do visual testing. And the reason being, so it's to do with anti-aliasing, partly in that, to the eye, things look perfect, but because of the way that they're actually rendered based on the different hardware on machines, tests will fail. So on the left-hand side, this was an image which failed. And what we can see is we've got the numbers again on the output image. So what a lot of the tools do is they introduce a tolerance. So what you do, you work out what the tolerance is between your machine and the build machine perhaps, or your colleague's machine, and you just set that in a config. You can do this automatically. You may be thinking, well, actually, how reliable are these tests then if I have to set a tolerance? It can still pick up a letter change. So we've tested on, I think it was 12px, and it picked up a character change, but it's just no longer pixel perfect. And a lot of the frameworks will say perfect to the human eye. They won't actually say it's pixel perfect, and I think Applitools is similar, but they do use AI, so they tackle it in a different way. Another approach may be to actually move your code onto a Docker image. So the thing that actually takes the image and does the comparison, it's the same image. So apparently, I haven't tried it myself. If anybody's tried it, I'd love to talk to you after, but apparently that gets around this issue. Again, quickly, storage. I'm going to keep on about this, but if you start taking, you know, lots of images of lots of different sizes, it's going to build up. It's going to take lots of time to try and maintain these things. And then you're going to have to weigh up, is it actually worth all the investment? Applitools, they do a thing whereby if images fail, they'll actually group them and you can approve or not in groups. So it helps with this type of thing. And it's cloud storage, or you can have local. Dynamic content is quite interesting. So there's lots of different ways. So you can just target an individual element. But what we've done is we create a helper and we say, find this element and blanket over it. So we basically inject JavaScript again. We find out the elements X and Y, its height and width, and we just put a blanket of color over it. And then when we take the image, the base image, it's already got the blanket. So every time we go to that page and we call the helper, it's just covering the dynamic content. So it's a workaround. Moving elements, again, inject JavaScript, stop CSS, 3 transitions, and you can just call stop in videos. So that's how basically a lot of the problems we've been injecting JavaScript. And one of the best things, I haven't seen a lot of people talk about this when they talk about visual testing, but you can visually check documents. So if you have, for example, we were testing manually going through a 30-page document, which took ages in a language that was foreign to the person checking it. You can use third-party providers, and you can actually extract the pages into an image and then run that image through the image comparison. So quite quickly, you can do a comparison of large documents. Again, PDF, dynamic content. A lot of the third-party providers, they offer a way of being able to use regex, find a date, mock it to something known, and then take the snapshots. So if you have a PDF that stamps a date, for example, you can get around it by looking at things like that. Very quickly, 2 things I've just added, short notice, and I'm running out of time. We've been testing visual testing with D3 charts. So we create our own framework. And what you can do is, again, through JavaScript, you can feed it a data set of known values, and then you can take the screenshots. So all of a sudden, you can check that your frameworks are actually rendering, and this is really powerful. And last but not least, accessibility. You can inject JavaScript again, and you can work out the actual flow of your application. So lots of people, when they talk about automation of accessibility, what they're actually referring to is checking the markup. But all of a sudden you start to actually test the usability or the tabability of an application, which not many people do. So it's really powerful. So very quickly, yeah, just because you've seen this, hopefully you'll want to try it. But you know, it's just another tool to your tool belt. Don't just use it because you can. Try it, see if it works for you. It may not work for you, but certainly take a look at it. That's the end of the presentation. There's a NuGet package, so you can basically create a brand new Visual Studio solution, run this command, and it will install Chrome WebDriver, lots of examples, and within a minute you'll be able to get your visual testing up and running. And you can start to feel, you know, is it actually adding any value? So rather than just trying to sort of stumble through it, you can do that. And there's also a link to my GitHub repository. It's really rough and ready, so please don't judge the code. But if you want to contribute, that'd be brilliant. That's all I've got today. Thank you very much for your time.